So we're going to find out, well, what was the value that we got for what the difference of the two was? Well, women was 0.881 and men was 0.849. So handy dandy calculator, 0.881 minus 0.849 is, we got a difference of 3.2%. Right? So somebody who didn't know their statistics would say, that's the difference between women and men. Women have a 3.2 percentage point higher graduation rate than men do. And a good stats person will say, well, that was your sample result. You don't know that that's the real result. You just know that that's what you got. And so that's why we're making the confidence intervals say, well, we got this, but we think the real value is somewhere in here. All right, so now let's finish off the rest of it. Plus or minus, right? The number of standard deviations, that's that Z star that we've done before. See, I'm kind of building the formula on this line, and then I'm going to put the numbers in and then work it out. So the Z star thing, times the standard deviation of our statistic, standard deviation, oh, that's that formula that we saw today. It's times the square root of P1, 1 minus P1. You can just put Q, that's fine, over N1 plus P2, 1 minus P2 over N2. Again, those are in the book and on your formula list, so you don't have to memorize that for the test. So, cool. Now, the one thing was today, we did that whole pooling thing. And the whole reason we did that, remember when we combined the proportions and we combined the men and the women, we put them all together in one big thing? It was kids, but you remember the situation. The reason we're not going to do that here, yay, is because notice we don't have any assumptions. In a confidence interval, we're not assuming that they're the same. We're not assuming that men and the women are equal. So we don't have any reason why we have to make a perfect value for what we expect these things to be. We're just going to put in the values we had. Now we want to put the real values in. We don't know them. So we're going to put in P hats and Q hats if you wrote it that way. We're just going to put in our best guess. We're going to put in, well, let's put in our sample results and see what we get. All right, here we go. So plus or minus Z star. Remember where that came from? 95% confidence interval. Ow, I just hurt my foot. 95% confidence interval. What's a Z star for a 95% confidence interval? Give me a second. Okay, it's 1.960. Right? That's still the same. Times that big thing. So the square root of P1, 849. 0.849 times 1 minus 0.849 over the number of men, 12,460 plus, these things are huge, 0.881 times 1 minus 0.881. Actually, I had the number up there, but I forgot that I already worked that out, 12,678. And now we're going to crank that thing out. Just to prove a point, well, I mean, it's not to prove a point, but just to kind of like help out. I'm actually going to work out what this number is right here for a second. So I'm going to do that right now. And yeah, it's going to take me a while. Sorry, I did not work this out ahead of time. So clear. I'll do the square root at the end. 0.849 times, it was over there, 0.151 divided by 12,460 plus, I'm getting to here, 0.881, just check and make sure I close my parentheses. I thought I saw a weird parentheses there. I did. 0.849 times that. Good. I should have worked this out ahead of time. Live and learn. 0.881 times 1 minus 0.881. I already got that. 0.119. 0.119 divided by 12,678. Whew, hope that works. That looks good. Square root answer. Okay. I'm going to double check this after it before I post this. I get that this whole thing works out to 0.0043. I'm going to check my answer before I post it. You might be like, whoa, that's kind of a small number. Remember what I said at the beginning? I was like, man, they surveyed 12,000 people. I think these numbers are probably pretty close to right. And even when you're combining them, you're still not getting enough where it's going to make much of a difference. It's going to be really, really close. So this number is really, really accurate, and this number is really, really accurate. So now I'm going to multiply these two together. You don't have to do this. You could do it all in one big thing, but I'll show you. I just want to remind you of something from earlier. Times 1.960, and I get plus or minus 0.0084. That right here, this right here, is my margin of error. Like, that's my margin of error in this one. It's about 1%. It's a little less than 1%. Nice job. Way to spend all that money to get a very small margin of error because your sample size is so huge. And then it's 0.032 plus or minus that. So I go 0.032 plus that number. And on the high end, I get that the difference could be 4%. And then same thing, but switch it to a minus. Ugh, minus. On bottom, it's, well, you know, there's a little bit of a range here. Let me write it clearly since it's actually a little more interesting than I thought. On the low end, it's 0.024. And this is 0.040. That's my confidence interval right there. I've got a range around 0.032 where I'm saying, I don't know if this number is exactly right, but it's really close. I don't know if this number is exactly right, but it's really close because of those things. So I found that women are graduating from high school or have graduated from high school 3.2 percentage points more than men. But if I had to make a range around that of what the exact number is, I'd say it's somewhere between 0.024 and 0.040. This is my confidence interval. Now I'm getting to interpretation. I'm not going to write this because, you know, we're running out of space and I don't know how far over I go. I am 95% confident that the true difference between men and women in their being high school graduates, I don't know if I want to say graduation rates. This is where wordsmithing comes in the percent of high school graduates, or the proportion of high school graduates in the adult population, that women are between 2.4 and 4.0 percentage points higher in their graduation levels than men. That was a tricky one. I just didn't want to sound like I was talking about high schoolers now. I'm talking about adults. And that was a little awkward. Right? But somewhere within this range is what the true proportion is, the true difference in the proportion between men and women, with women being higher. Last one, evidence. Is this evidence that more girls graduate from high school? Yeah. I mean, because we think the true proportion is a positive number. So when you do women minus men, we think that it's going to be a positive number, so women are higher. That's number 10. I hope that helps you with number 9. Get that? You know, the way we're working things here. So that the idea is that this is pretty similar to what you're going to do on number 9, and I hope it clarifies some of the weirdisms. I guess the one thing I'd emphasize, just thinking about stuff that might have been unclear, is that whole pooling thing that we did today in class. I was kind of taking on the hard part. You don't have to pool unless you're assuming that the two are the same. If you assume that the two are the same, it really makes sense to say, oh, we shouldn't put in two different numbers here. We should be putting the same number in here. And pooling gets you the big proportion of what it should be. But in a confidence interval, you're not assuming anything. So you can leave them separate. I think that's it. Hope that helps. Send a message or post a discussion item if you have any questions. Bye.